Safety Toolbox Talk number 347. Dust and respiratory protection. 1. Why dust matters, health risks. Inhalation of airborne dust can lead to severe, long-term health problems. Dust particles, especially the fine ones that are hard to see, can get deeply lodged in the lungs and cause serious diseases. These diseases are often irreversible and can shorten workers' lifespans. Health conditions linked to dust exposure. 1. Silicosis, a lung disease caused by inhaling crystalline silica dust from materials like concrete, stone, and sand. It leads to fibrosis, scarring, of the lungs, making breathing difficult and can be fatal. 2. Asbestosis, caused by inhaling asbestos fibers. This disease can lead to lung cancer or mesothelioma. 3. Chronic obstructive pulmonary disease, COPD. Long-term exposure to dust can cause COPD, a group of lung diseases that block airflow and make it difficult to breathe. 4. Occupational asthma, a condition where dust particles, particularly from chemicals, irritate the airways and cause asthma-like symptoms. 5. Lung cancer. Long-term exposure to certain types of dust can lead to lung cancer, particularly asbestos and silica dust. 2. Types of dust. Visible dust versus respirable dust. Visible dust. This is the dust you can see floating in the air. While it may appear hazardous, it's often too large to be inhaled deeply into the lungs. Respirable dust. This is fine dust that is not visible and can be inhaled deeply into the lungs. It's small enough to travel deep into the respiratory system, causing damage over time. Dangerous dust particles. Silica dust, found in concrete, stone, and sand. It's the most hazardous type of dust, causing serious health issues like silicosis and lung cancer. Wood dust, often found in woodworking industries, it can cause respiratory problems and is a known carcinogen. Asbestos fibers, often found in older buildings and certain insulation materials, it causes asbestosis, lung cancer, and mesothelioma. Coal dust, common in mining industries. Coal dust can lead to a disease called black lung disease. Three. Hazards associated with dust exposure. Long-term respiratory damage. Prolonged exposure to dust can cause chronic lung diseases, reducing lung capacity and leading to early disability. Acute respiratory issues. In the short term, workers may experience coughing, wheezing, and shortness of breath when exposed to dust. Increased risk in certain workers. Workers in industries like mining, construction, and demolition are at a higher risk due to continuous exposure to harmful dust. Environmental hazards. Dust not only harms workers but can also negatively affect the surrounding environment, polluting air and water sources. Engineering controls. Dust extraction systems. These systems help capture dust particles at their source, preventing them from entering the air. Examples include local exhaust ventilation, LEV, vacuum systems, and dust collection systems. Wet methods. Water sprays or wet cutting methods help minimize airborne dust. Wetting materials before cutting, grinding, or sanding prevents dust from becoming airborne. Air filters. Use of high-efficiency particulate air, HEPA, filters in ventilation systems or exhaust fans can capture fine dust particles. Administrative controls, work practices, implementing work practices that minimize dust generation. For example, avoid dry sweeping, it stirs up dust. Use a vacuum or wet mop instead. Use of wet cutting tools, wet saws and drills significantly reduce dust compared to dry methods. Job rotation, to minimize exposure time, rotate workers in high dust environments. Proper housekeeping, keeping work areas clean reduces dust accumulation, making it easier to manage exposure. Personal protective equipment, PPE respirators. The most effective form of protection when controlling dust isn't fully possible through engineering or administrative controls. N95 respirators provide basic protection from non-toxic dust particles, such as wood dust. P100 respirators provide higher protection, suitable for more hazardous dust, like silica. Half-face or full-face respirators. For high-level exposure, a half-face or full-face respirator with replaceable filters can offer better protection. Dust masks, lightweight and comfortable, but they offer minimal protection against fine dust particles. Proper mask fit. Ensure the respirator fits well to prevent dust from entering through gaps. Beards, facial hair, or improper fit can reduce effectiveness. Selecting the right respiratory protection. Fit testing. Ensure that workers undergo fit testing to check if their respirator fits properly. This is critical to making sure the mask provides the necessary protection. Types of respirators. Disposable dust masks, N95 for low-level, non-hazardous dust like wood dust. Half-face respirators, for higher exposure levels, e.g. cutting concrete or drywall. Full-face respirators, for highly hazardous environments like mining or asbestos removal. Powered air purifying respirators, PAPR for environments where dust levels are very high, offering filtered air through a battery-powered fan. Training and awareness. Educate workers. All workers should be trained in the dangers of dust, proper PPE use, and the importance of engineering controls. Safety monitoring. Regularly monitor the workplace to ensure dust levels are within acceptable limits, and PPE is being used correctly. Health surveillance. Implement health checks for workers regularly exposed to high dust levels, ensuring early detection of diseases. Thank you.